Hi, I'm Miles Berry. I'm Professor of Computing Education at the University of Roehampton, where I train the next generation of, particularly this year, outstanding teachers. I saw at least one of my current mentors and one of my former mentors in the room. So huge respect to you both. Thank you very much for the work that you do to contribute to this. Roehampton let me out to do other interesting things. So I'm currently chairing the NCCE's academic board and the BCS's England Computing Curriculum Committee, and having finished that, I think that's all of my time up. No, so I want to talk about creativity and curiosity, but there's quite a long lead up to the interesting stuff about creativity and curiosity. And my first entirely rhetorical question, folks, is, have we got a problem? Is everything in the garden rosy with computing education? Are you entirely satisfied with how everything is working in your school? If that is the case, come back in about half an hour's time and we will talk about creativity and curiosity. But if you feel that there are issues with this, then I think you may be in good company. I spotted this on the Facebook page, one of the many Facebook pages, a couple of years ago now. Anyone got any tips for an uninterested class? I'm an ECT and have some issues with 8 out of 14 students in a Year 10 class having absolutely no interest in the subject, and thus no interest in doing any work. The school never had a specialist CS teacher through Key Stage 3, so everything on the spec is pretty much new to them. For some reason, they thought they would be building computers during the course. It's all been a shock to them that it is so theory-heavy. They won't do any work in the class unless I go around and push them. And as soon as I move away, they just stare blankly at their screen. Okay, so is the person who wrote this in the room? Yes? Okay, right. This wasn't. No, this cannot have been you. No. Okay, it's a familiar context. Okay, I do not believe for a moment this is Rohini talking about this. Okay, anyhow, what would be your advice? How do you solve a problem like this? Mark?
Get them to take a good computing apart, look at all the bits, put it back together and start discussing from where they're at.
Yeah, I think you're meaning bit in a physical rather than binary sense at this point, because that takes special skill. But yes, you're absolutely right. We've got a clue in the question here, haven't we? What are these kids interested in? Building computers. So let's build a computer, and I can do so much of that stuff around the mechanics of a computer, how the components, all of that stuff about the hardware, I can do physically with an old computer. What am I talking about? We're talking about schools now, with a computer, and just build the thing, take it apart, put it back together again, switch the thing on, and hope that it works the second time round, even if it didn't necessarily the first time round. Anybody any clues as to how this situation arose, though? Thank you.
They weren't made aware of the spec in the choice.
Well, they'd not read the spec before their GCSE choices. How astonishing that they'd not actually read the detail. They'd not been, yeah. Oh, yeah. They hadn't been briefed properly. I mean, reading between the lines now. But my guess is it's one of those lovely Year 9 options evenings. You want to win people over to your subject. You've got to, have a good subject group for next year. What are you going to do for computing? I know. Let's put all of the component parts of the computer up on a green baize table, show them, oh, look at all of this cool tech, well, old tech, that we get to play with. That's going to be so cool. Kids turn up in September and look what it is. It is, okay, here is a worksheet, here is another worksheet. This is going to be theory on the exam. And there's a bait, I suspect there may have been a bait and switch going on here as well. But, we've got a way forward with this, which is find out what the kids are interested in and start with that as your hook into the subject. Now, n=1 is not reliable here. Are there other issues? Well, back in 1989, before Ofsted became Ofsted, they did these amazing subject survey reports when HMI were there to help teachers. No criticism of Ofsted is implied. The study of computing can and should be stimulating and fascinating for pupils. Please put your hand up if you agree. Okay, that's really, that was a moment there. As experienced by many, it is sometimes dry, dull, and unexciting. I'm not going to ask for a show of hands there. Thank you though, Mark. Not at your school, I know. Right. So look, that was then. Somebody do the math for me. 35 years on. Is it that much better? You will remember this speech, I'm sure. Okay. Some of you will remember Michael Gove. I normally get a cheer at that point, but never mind. Okay. Instead of children bored out of their minds being taught how to use Word and Excel by bored teachers, we could have 11-year-olds able to write simple 2D computer animations using an MIT tool called Scratch. If you've not seen it, it's really, really good. By 16, they could have an understanding of formal logic previously covered only in university courses. Oh yes, that Boolean logic goes down really well, doesn't it? And by writing their own apps for smartphones. Okay, I'm talking to an elite audience here. Please put your hand up in the air if you have had, by the age of 16, kids writing apps for smartphones. Okay, as I say, it's an elite audience. I'm not going to infer that that is generally the case, but well done, folks. That's good. So look, there does seem to be an issue. They join you in year 7. Oh, you know what they're like. They may not know how to use a mouse or save their work, but they do seem enthusiastic at that point. That's nice, thank you. And 68%, 2/3 of them, say they find the subject very interesting, faint praise here, or fairly interesting. Yeah. By the time they get into year 11, we're talking about only 1/3 of them who are still studying the subject, finding it very interesting or fairly interesting. What have you done to these kids? You know, please don't blame yourself. But Andy.
What's that like for other subjects?
Oh, yeah. So that's a good question, and thank you for being somewhat sceptical. This is from the Royal Society's Science Tracker, and it is a similar picture over in science as well. We don't know about, the cool and fun subjects. Sorry, the other cool and fun subjects on the curriculum, but this does not seem peculiar to computing, so please do not blame yourselves. Yes, all right. So, fair point. Okay. So I will fess up here to being the current chair of the NCC's academic board, which has been doing so much around creating a computing curriculum and subject support for teachers and all of those lovely Isaac resources over the last, I don't know, what are we talking here? It's 4 or 5 years of this now. It's probably more than that. I would just like to draw your attention to, back in 2019, 50% of kids thought that this was interesting or fairly interesting. Now it is merely 48% of them think this is interesting or fairly interesting. I'm not taking all of the responsibility for that, but there's an issue, I think. I think there is an issue. And I think amongst ourselves we can be honest about this. The DFE do the survey, so why are you not thinking about taking GCSE computer science? 2/3 of the kids who they asked said, I don't like computer science. It's a good reason for not doing the subject, isn't it? But wouldn't it be nice if they did like computer science? I find it hard. Again, that's a good reason, and perhaps we've not done very much to make it easy. Will not help my career. These are good reasons that they're giving. But I do not like it. That's not a fixed thing. We might be able to do something about that. This time around, the DFE actually asked them, okay, you say you don't like it. Why don't you like it? Year 7 to 11 pupils who said they did not like computer science were asked to specify why they did not like it. The most common reason why they did not like the subject is they did not find the subject interesting. I think they just said, I don't like it because I don't like it. There's no information has been added here. They did not enjoy programming or coding. Other reasons are given there. So there is something by this point that they are not enjoying a thing, which those of us in the room today find so fascinating and fun, and this is even better than computer gaming most of the time. My former colleague Pete Kemp did an amazing survey of asking kids in really good schools with good gender balance for the subject, with good uptake of the qualifications. Tell us about your experience of this. Reasons for not choosing GCSE. Doesn't fit my career ambitions. That's a good enough reason. It's not enjoyable is the one that really stands out there. And notice the difference between the green column for the girls and the purple column for the boys. 73.9% of the girls that he has said, I'm not going to do this because it's not enjoyable. I think this is fixable, folks. Oh, and you saw that downward curve. Yeah, if you look at that on gender, then okay. So the orange dots are everybody. For the girls, 21% by year 11, find this subject interesting or fairly interesting. There's a huge gender split there, as you know about. I can show you the GCSE uptake figures. This is from last summer. It's getting better and better every year. This is an improving picture. Well done, but it's not improving enough yet. Yeah? So computing is down there. As I say, it is improving. 24% of the cohort are girls now. At A-level, we are the worst subject in JCQ's table, with less than 20% doing A-level computer science. I imagine there are conversations going on at the big performing and expressive arts leadership conference where they're saying, why aren't there more boys doing our subject? But I don't get invited to those things. So how do we go about fixing this? Some of it, I think, is around what we teach, and some of it may well be about how we teach. I'm going to deal with the what we teach first, if you'll let me. So, turn and talk, or think, pair, share, depending on your school culture. But what is the most important thing in Key Stage 3 computing? No more than 2 minutes, probably less than that. Anybody? I think this is still working. Okay. Has anybody got an answer for me then? What's the most important thing in Key Stage 3 computing? Okay, I don't know what you've been talking about, but come on, I'm going to just have to do cold calling here. Right, yes, sir.
That it's not magic. Everything the computer does is explainable.
I love that. Yes, that you can just reason about this. That, as you say, it is not magic. There is a good reason for this. Even with the AI stuff?
Yeah.
Yeah, absolutely. Okay, anybody else? Yeah.
Being transparent about the bridging step from Key Stage 3 to Key Stage 4.
Okay, being honest with the kids, not lying to children. Okay, this is fine. Anybody got a very different answer yet? Oh, okay, this is just, I could have just stayed in this bit of the room. It's fine.
Sorry, we're all in this corner. I think it's about making stronger links to your primary schools. Actually going and looking and seeing what primary schools are doing and then building from that.
Yeah, because the science tracker starts at year 7, and I kind of think primary may be okay. Siobhan, last.
It's not so hard. It's not as hard as people think it's going to be, particularly girls.
Oh, selling the message that actually this is well inside your capabilities, you can do this. Not, these... I'm going to carry on, Andy. Talk to me later. None of you have got the whole thing about what is inside the teacher's head. What do I think the most important thing is in Key Stage 3 computing? It's engagement. The secret of your success in Key Stage 4 computing is that they're having a really positive experience in Key Stage 3 computing. That I do not enjoy the subject becomes a far, far less common response to the... You're not going to win them all over. They're teenagers, you know what they're like. But giving them as positive an experience of the subject at Key Stage 3 as you possibly can. Not just because you want healthy groups in Key Stage 4. You will, I hope, get healthy groups in Key Stage 4. Because this is fun and amazing and really good fun. Okay, I want to move on, but you look as though you need to say something at this point. Okay. Catherine.
Key Stage 3 is nearly always relied on by non-subject specific specialists.
Oh, okay. Right, so we've got to sort out, let's get a load more teachers. Okay, I'm doing my best, Catherine, I really am. Yes, okay. If any of you happen to have friends who would like to train to become computing teachers, I have a very good course I could recommend to you. Other training providers are available. Okay, does anybody recognize the text on this screen? What is it, sir?
It's the one you get on the government website, isn't it? National Curriculum.
You think this is the Key Stage 3 National Curriculum Programme study? Maybe. It looks a lot like it. It's like written in that style, is it not? Anybody know what it actually is? Because I'm afraid that is the wrong answer. Do I have to do that like trendy teacher thing? That's interesting. Why? No, is the wrong answer. Okay, right. Anybody know what it really is? This is what we wrote. So I was part of Simon's committee that wrote the Key Stage 3 programme of study. We sent it off, I'm trying to do the math in my head here, 12 years and about, 12 days ago to the DFE saying this is what we recommend as your programme of study. The minister said, thank you very much for your work, it's lovely to read that, thank you, well done. There are a few changes I would like made. So the last bullet point, critically evaluate digital content, including its context, provenance and trustworthiness, reflect on the personal, social, economic and ethical impacts of technology and technological change and the implications for rights, responsibilities and freedom, you will not find in the Key Stage 3 programme of study. Why the minister insisted on the removal of any reference to ethics is left as an exercise for the audience at this point. The minister did say we need more maths in here. So hence you've got to teach kids how to do binary arithmetic. It turns out that I have a very good machine, a machine which is very good at doing binary arithmetic. That's kind of how it works. There's also stuff in here about Boolean logic. I'm not saying that these are bad, but you may feel that binary arithmetic and Boolean logic matters a little less than the, critically evaluating digital content and thinking about personal, social, economic, and ethical impacts of technology. Given the choice, which of these is going to be more useful in later life? Do not answer the binary arithmetic. Okay. Some of you may figure out who was the minister at the time. Not the Secretary of State, the junior minister who was looking after curriculum change. Go on, Will. It was Liz Truss, yes. What did she go on to do? To be fair, changing our lovely work into what you've been working with for the last 12 years was not probably the biggest mistake of her career. But, we should have known. We should have known. Okay, so what do we end up with? This. Again, this is Pete Kemp's and colleagues' work for King's for this scary computing. I love the name of the research, scary computing. The arrows that you're looking at there, where the arrow is green and sloping up to the left, it is where the girls in his sample find this more interesting and find this easier. They are Digimedia, Project, and Present. The bits where the arrows are sloping down to the right are where the boys find it easier and more interesting. That is programming, hardware, maths, and network. You will notice that the list I have just given you is a significant component of the GCSE specification. And we are surprised that we don't have a better gender balance. We seem, not by deliberate choice, I know, to have put together a GCSE specification which appeals to one part of the cohort much more than it does to the other part of the cohort. I'm not saying we intended it that way, but that is how it's turned out. I was chatting to my daughter who is in Year 9, it's 3-year Key Stage 4. She has chosen to do GCSE Computer Science because she's persuaded 3 of her geeky friends to do it with her. She's not going to be the only girl doing the subject. She's having a great time with it. Anyhow, so I was chatting to her about this gender issue. And her quote, I think, just sums it up so well. We, the girls, are interested in what we can do with computers. They, the boys, are interested in what computers can do. It's really hard to put it any better than that, isn't it? Perhaps our curriculum needs to be both. So Pete, again, slightly more than my n=1 sample here. Why did you choose to do it? Again, by gender, and you're seeing the peaks there, the ones that really stand out. My future options, I enjoy it, and it's career, future options and career, I see very similarly, and it's a creative thing. Hold on to those ideas. It's enjoyable, it's creative, it's relevant to my career path. If what you're doing with computing in your department, in your school, ticks those boxes, then I think you're doing a pretty good job. This room is likely to be doing a pretty good job. This is very consistent with other findings. So this is from the science tracker. What are the top things there? They find it creative, they enjoy it, they have a good teacher. Well, your pupils are fine. It's relevant to real life. Oh yeah, and I get good marks in it. Again, the DFE survey, I like computer science. I'm good at computer science. Computing science will help my career. They asked then, why do you like computer science? Because I like it. They find it interesting. They enjoy the programming. They enjoy learning how to use computers. They enjoy their lessons is up there and the opportunity to be creative. So we've got a very consistent set of responses, I think. It's enjoyable, it's creative, it's relevant to my career path. Okay. Who responded to the CAR, personally or on behalf of their school? Curriculum and Assessment Review. Thank you. Well done. Okay? I would very much like to hear a little more about what you said. BCS responded, I helped with the process of facilitating the BCS response, which is summed up in a not entirely representative quote on the screen there. But, you know, at this point we need to say there are issues. Too many teenagers put off by abstract and unmotivating computer science GCSE. Okay? Not computing, the GCSE spec is the problem. Because this is what we have. Key Stage 3, it is computing. Somebody was saying about the breadth of the... Simon, when we were chatting, it's the breadth of the subject there, and absolutely right. Then you get to GCSE, and you're only going to do computer science. If you want to carry on with it at A-level, you're only going to do computer science. If we were to do other subjects like this, we would teach them the whole of science up to the age of 14. We would leave science as the curriculum subject, but we would only allow them to take a GCSE in physics and only allow them to take an A-level in physics. We probably wouldn't have done it that way. Okay? So where do we go from here? There are multiple things we could do. So one popular idea is carry on with the computer science. It's going fine, thank you very much, but introduce some sort of digital qualification. I am not calling this a driving license, let us be clear, at the end of Key Stage 3, that everybody takes that and demonstrates their ability to use technology. My preferred option is the middle bit there. Everybody does computing to the end of Key Stage 3. Then we have a GCSE in computing, IT, digital literacy, computer science, and then I would go even further and say the A-level is a facilitating subject for anybody who's going to go off and do STEM or numeric disciplines post-18, not just those who are going to have to repeat the same content all over again in first year when they get to university. Another option, this is Yuki's model, I think, computing Key Stage 3. Nobody's saying anything about getting rid of that. Possibly some of the Liz Truss changes could be reversed for this, if not for everything else. And then computer science carries on into A-level, and then a new digital creativity GCSE sitting alongside the computer science. I'm not too averse to that. Anyhow, you will have your own thoughts on that. I would love to hear them in break time, not now. Okay, the other thing I want to nod in the direction of, before we get to the interesting stuff, is how does all of this amazing, do not anthropomorphize, do not attribute this to magic, AI. So Simon shared a photograph of him at a tender age. I felt I had to do the same. I don't know exactly how old I was then, but I am fairly certain that it was roughly this age that my father brought home the box on the right there. And I must admit to you that I failed to invent the binary number system by the age of 7. We pay respect to those who can. But I did get interested in tech. And it's partly down to my father, who was also fairly geeky and techie, and brought home one of these calculators. This picture is nicked from Etsy. Etsy, I don't know how to pronounce it. You can buy one of those at £193 now. I wanted to sort of do the inflation if he had kept it. And anyhow, it does, it's a basic 4-function calculator. This is not rocket science. Young Miles there, though, is in primary school, being taught how to do multiplication tables and addition and all of the things which my father's magic box there will do immediately. It's not magic. I know it's not magic. There's I don't know, genies inside. I don't know how this thing works. So, the question I had for my primary school teachers, and I think I might even have asked this because I was that awkward back then. Some things change, some don't. Is, why are we still having to do this on paper when that can do all of this, yeah? And of course, this is ages ago. You can tell how long ago it is. But it may surprise you that we are still teaching children to do arithmetic on paper, and we're still testing their ability to do that. No calculator papers in the primary school SATs. There is a mental arithmetic paper, which is incredibly dull. Go and have a look at it if you don't believe me. So this is not entirely rhetorical. One good answer to this. We'll see how long we have to take until we get a good answer. Why are we still teaching kids how to do pencil and paper arithmetic throughout primary education and much of secondary education? What's the point of that now? Perhaps it was a rhetorical question. Okay. Yes, sir?
Because how are they going to build on that if they don't have that knowledge? As everything else is higher and harder to be doable
So you've got to learn to do it on pencil and paper because that's the only way you'll be able to use it later.
Not necessarily
Okay.
like the foundations.
Yeah. That it is laying a foundation, isn't it? There's hands over the side of the room there. Okay, loud voices.
Is there not a social aspect because not everybody has a calculator? You will do what everybody has, and so you will socially conform because you program little boxes and you are a box.
Oh my goodness. So we are teaching them to do things in a particular... Yeah, there's a whole sort of imposing society's expect. I think there is also an element of it never did me any harm. And to be fair, it didn't do me any harm. But saying that's the best thing for the next generation, I can't argue from an is to an ought. Yes? And I think that's what your colleague over here is getting at, isn't it? That without going through that really quite tedious pencil and paper stage, you're not going to have your model in your head of how mathematics, or at the very least arithmetic, works. And that's why I'm fairly confident to say it didn't actually do me any harm, even if I couldn't invent binary by the age of 10. But there you go. So, why teach arithmetic? Because it's good for you, because it keeps you in your place, perhaps. But I'm much more persuaded by the argument because without learning it yourself, you won't be able to make sense of the computer doing it for you, or the calculator doing it for you. I think that's a good argument, personally. Okay, so this is Nimotron. Nimotron was at the Chicago World's Fair in 1939. This is 1939-1940 technology. This is done with electromechanical relays. They built this thing, there was queuing round the block, and it would play a perfect game of Nim. Put your hand up, please, if you've ever heard of Nim. Hey, that was much better than we got at the beginning of the day. That's really good. Okay. So, I say to Claude, I kind of feel there has to be a French accent for Claude, but there you go. Can we play Nim together? You should go first. You must try to beat me. Okay, and it starts with the 753 thing, and if those of you who can do bitwise XOR in your head will know that new position here is a losing move. Told it to beat me, and it's made a mistake here. Is it just playing the long game? It needs to demonstrate that it's going to pass a Turing test by not being able to do this perfectly? No. It is just putting down tokens. It's just guessing what is the next likely thing. It's not thinking about how to play Nim. It looks as though it's playing Nim, but... Okay, it is playing Nim, but it's playing it very badly. All right, okay. You've taken the last from part 2. This means you've won the game. Congratulations. Thank you very much, Claude. Okay. Do you want to play again? Do you want to play Global Thermonuclear War? No, that's a different film, isn't it? I'm happy to explain the certain moves. Then I take it a stage further. I say, okay, write me a simple Python program that plays a perfect game of Nim. Certainly, here's a simple Python program, and it does. It can't play it itself, but it can write the code that does that. Can you use the model view controller pattern to make this into a 2D GUI game using Pygame as the library? Yeah, there you go. Okay, I think that's pretty much all of an A-level coursework done. Terms and conditions apply, but somebody grade this for me. I'd be very happy to have, do the resets now. And then, inspired by Becky earlier, now could you give me make this a, what was it, clickable prototype? So on a good day, we should be able to play Nim together against the machine now. Who's got the game off pat? Who knows how to win at this? Who can do bitwise XORing in their head? Nobody volunteered. So can I just ask you to choose, make a move, Chris. Where are you going to take from? Pile 1, pile 2, pile 3?
Pile 2.
How many matches? 3 matches from pile 2. And you can feel the sigh of relief from the vast server farm on which I may be using this now. The computer is thinking. It takes 6 moves from pile 1. Chris, do you want to carry on with this?
Yeah, why not?
You've lost, but carry on.
Yeah. 2 from pile 3.
2 from pile 3. Why not? What's the worst that can happen? It takes 2 from pile 2. Over to you, Chris.
1 from pile 1.
1 from pile 1. Just wait for the smugness here. Okay, well done, Claude. Okay, so I love the fact that whilst you were talking, I could just issue those instructions and get the thing spun up. It would take me considerably longer to code it. I think it might even take Simon longer to code it, but I could be wrong. Okay, yeah. He knows how to play the game, which is the main thing. So that then takes me to this sort of thing. For all but the very specialized application, most software will be replaced by AI systems that are trained rather than programs. Programs will themselves be generated by an AI rather than coded by hand. So then, folks, what are we all doing here? Which I think was the question Simon asked. Why are we here? No. Why teach coding?
Because which prediction about the future ever came true?
Okay, because there's going to be a techno-apocalypse in which the AIs are removed, but we still have computers. I love the way you're thinking there. That's a middle path. Yeah, okay, maybe not. All right. What's your convincing argument for the 16-year-old who comes to you?
It teaches more skills. It's not just about coding.
It's not about the coding. Fine. Yes, Andy.
Becky before lunch was saying that the number one thing that employers are looking for is problem solving.
I like that. I really do. That this is, despite this is Siobhan's, this is a really easy subject. No, it's not, I don't think. I think the challenge of it is where the fun lies. You have pupils who are going home to play computer games that are way harder than any homework you or your colleagues set. And they love that challenge. The challenge is not bad, but we have to be upfront and honest about the challenge. And yeah, sticking at things, persevering, solving interesting problems, breaking things down, computational thinking 1.0 if you must, all of that still seems entirely relevant. Coding is a means to that end. Just as you managed to convince me that pencil and paper arithmetic is a means to an end of understanding mathematics. I think that's where my answer lies. Anybody else like the Willingham quote? You'll have heard it in too many staff meetings by now. What is it? Memory is the residue of thought. The more you think about a thing, the more likely you are to learn the thing. If Claude just comes along and says, yeah, here you go, there's your program, I'm not going to learn how to make this. Of course I'm not. And the learning how to make it does seem to matter. So because the AIs can do all of this now, who knows what they'll be able to do in 10 years' time, maybe less, maybe more, it's fine, but the computational thinking about how to solve the problem, this is an interesting problem, these are interesting questions, I think remains valid. Just, the actual coding bit, perhaps I will outsource that to the AI. That's what a lot of software engineers are already doing. But I still need to understand the bits there. This is Sal Khan Academy. You have to be able to read and or code well enough to put the AI-generated pieces together. He, I think, is right. He goes on to tell us that there are likely to be other jobs that are very human-focused. I think you may have one of those jobs. Yeah? All you do is set work and mark work, be worried, but that is not all you do. Yeah? Inspiring kids to learn something that they're not already interested in is part of this. Robots write poetry and paint is not the future I wanted. So what matters about our subject? What are the bits that we want to keep? Turing said in 1950, in about 50 years' time, you'll be able to have computers that pass themselves off as humans. He was a little pessimistic with the figure, but 74 years later on, we're pretty much at that point. Show me 2 essays submitted for one of my assignments. I'm fairly certain that the better essay is the one written by the AI now. I'm teaching computing education, so it may be different over in English, but we are at that point where it's writing better than my postgraduate students. It's not teaching better than them. Please be clear about this. Before I get to use ChatGPT, I have to put a tick in this box. All right? This is a machine asking me to prove that I'm the human being. Okay? Listen, when GPT-5 comes out with the ability to put a tick in this box, be afraid as to what else it's going to be able to do. So, folks, what makes you human in addition to your ability to be able to put a tick in a box or count the number of, or identify photographs of a zebra crossing or whatever the other tests are? What still matters? What is important for your pupils? It may not be the ability to code. Problem solving is probably on the list. Do you remember this one? Barefoot, the original poster, the stuff on the left, which is still what you're teaching, year 7 computational thinking, what is an algorithm, what is decomposition, which of these is an abstraction of a bicycle, all of that stuff, I suspect the machines are really quite good at. The stuff on the right, not so much yet, okay? The stuff on the right is where I would like to see CT 2.0, 2.1, whatever version number we're on now, heading, is these things remain just as important inside our curriculum. And playing with this, tinkering, making stuff, more of this later, fixing it when it goes wrong, even if it's the machine's code that goes wrong, yeah? And keeping going when it gets hard. And yes, working with other people, perhaps working with some of the machines, not anthropomorphizing them there, but being able to work together with other people, with AI assistance. So the things that still matter, I think, he eventually gets to the topic of the talk, curiosity and creativity. Yeah, high up my list there. I don't know whether the AIs are genuinely creative, but I know that the best pupils, students, trainees I've taught have been creative, and that matters rolling forward. It really does. And yeah, curious about these things. I don't think GPT, Claude, whoever, is curious about the world. I hope it isn't, in all honesty, but the best trainees, pupils, students I've taught have been curious about the world. If you gave me longer, we might also talk about character, and integrity, and criticality, and being able to form a view, and the courage to do the right thing. And yeah, courtesy. I'm still usually one of these people who say please and thank you to the AIs. Am I anthropomorphizing? Or am I training it, literally training it, so that when it is a bot looking after me in the care home, probably quite soon, it's going to be reasonably courteous towards me? I don't know. Okay, so quickly, curiosity then. Oh, you know this because you love your subject, yeah? But the emotional effect of the things that we study in school or the things that we have learnt matter. We humans cannot divorce ourselves from our biology, nor can we ignore the high-level sociocultural and cognitive forces that make us special. When we educators fail to appreciate the importance of students' emotions, we fail to appreciate a critical force in students' learning. One could argue, in fact, that we fail to appreciate the very reason that students learn at all. It's an emotional thing for them. For good or ill. So which is the emotion that characterizes your current Year 11s, please? Yes? Is it the purple picture? This will be on the exam. Just think how awful it is going to be if you're there in the gym in June and you do not know the thing. Or is it the blue thing on the right about, oh, this is so exciting, this is so interesting? I worry that we focus too much on the negative emotion here and we've lost the joy and the beauty of the subject. Even Doug Lemov, yeah, the finest teachers, look around you, offer up the work with generous servings of energy, passion, enthusiasm, fun, and yes, humor. I think you probably are doing this with your classes. But if you want them to see the subject in a joyful mode, then perhaps passing on something of your joy in the subject might not be a bad idea. So look, you saw what I looked like at primary school. My primary school was deeply influenced by the work of Plowden's Committee on Primary Education. Plowden wrote back in 67, wasn't it school in 67, that was later, at the heart of the educational process lies the data. Sorry, at the heart of the educational process lies the P8 measure. No, at the heart of the education process lies the child. Yes? Wouldn't probably find that coming from a government committee these days, which may be a shame. One of the main educational tasks of primary school is to build on and strengthen children's intrinsic interest in learning and lead them to learn for themselves. I kind of feel like an EEF metacognition report coming on, but no. Okay, this is about not what you teach them, but you teach them how they can teach themselves things, I would hope. Okay? Teaching standard 4, none of my trainees can qualify, Siobhan, notice, right, unless their mentor says they promote a love of learning and children's intellectual curiosity. Yeah? That's on the list. Those of you trained in the last dozen years, at one point in your career, managed to convince somebody else that you could do this. I hope you're still doing it, yes? Promote a love of learning and children's intellectual curiosity. Until 2018, our friends at Ofsted, hello my friend at Ofsted, thought this was important. Pupils love 2018 Ofsted Inspection Handbook. Pupils love the challenge of learning and are resilient to failure. Curious, interested learners who seek out and use new information to develop, consolidate, and deepen their knowledge, understanding, and skills. That's not bad for a criteria for, is this a good school? Outstanding, we don't call them outstanding. Outstanding in one aspect, school anymore. That's good stuff. Who would have thought that the 2018 Ofsted Handbook included the word love in it? The 2019 edition of the same document does not include the word love, but it does now say pupils consistently have high positive attitudes and commitment to their education, highly motivated and persistent in the face of difficulties. These aren't bad things, but my suspicion is that's typically interpreted as have they handed their homework in on time. When you see the phrase in Ofsted inspection reports, that's usually the context of they turn up to lessons, they work hard, they do their homework. I've not seen many mentions of, and the kids love their subjects. Do you have any influence on the people up in town? Get them to put the word love in the next edition, please, Ellie. Okay. And more about this. So this is, quality teaching in English. Our emotions, urgent desire to find a piece of information. Motivates us to find that information, made use of it, made connections. We feel good about ourselves. Yes? Your experience? Your pupils' experience? Okay, we are motivated to go out finding out and processing more information from the same book. Our best students, I would say this is all our students, digest and absorb far more information through question asking and question making. So it's flipping this. I'm doing all of the talking this afternoon, but getting your pupils to ask you questions rather than you keep asking them questions. And Pete mentions this in his scary computing report, more likely to engage in computing if they see it how it relates to their lives and experiences, connect with their interests and values, real-world problems and opportunities. I think questioning is one great way of doing this. Anybody want to share with the room now a question they have been asked? I am not looking for, what should I do after question 3, please, miss, sir? Okay? A question they've been asked in class. I hope you're not saying anything because, almost there are just too many to think of here, yeah? Is it a culture in your school where the kids will? Why is it, or how do I, or do you think that? Good, I'm glad there are nods. I have 2 recent examples. So one was a trainee who I saw earlier this week. Kid asked at the end of the lesson, so is a web browser a database? Clearly, it would be so easy to laugh, but the child is thinking about it and interested in this. That's awesome. It really is. Previous term I had, why is it 70 years? So why does the term of copyright expire 70 years after the creator's death? Yeah? Well, it could well be. Okay, Mickey Mouse questions. Well, in a sense. But my trainee had inspired his class so much about intellectual property law that they wanted to ask why that particular number. I just think that's such, that's the sort of teaching I would very much like to see. There's a thing, William, I think this is in your book, or at least I got the idea from your brilliant book, this notion of the fertile questions. So you start with questions that breed other questions. That's where the fertile idea comes from. So it's an open question, an undermining one which challenges assumptions, something which is a rich question, where it connects to other things, where there's an ethical dimension to it, where there's a practical aspect to it. If I've not spent so long on the depressing news at the start, we would break into small groups and have a go at what are fertile questions for us. I will leave that as an exercise for you for the drive home. There are plenty that you could come up with. Let me move on then now to creativity. So, Prim. Isn't it brilliant? This whole read the code, predict what it's going to do, run it, investigate, modify it, make it your own. That's so good. Did anybody notice anything I had missed out there? How are we spelling prim at the moment? P-R-I-M-M, yes. The last M is neither silent nor invisible. Okay? What is the last M? Make, yes. My worry, very little evidence to support this view, is that very often we get as far as the first M. Hey, well done, kids. You've taken this code, you've modified it, you've done something, you've learnt this. And, oh, the last M is just so much harder. Let's just leave it there, yeah? Please reassure me that that's not how it is in my class. Good, I'm glad, okay? But the last M matters, okay? It really does. Make stuff, Mark.
We have more makes as well.
More makes. Oh, prim with a third M. That's really good. Yes. If they've made a thing, go make another thing. Yes, good, okay. So, Royal Society 2017, active learning. Get them doing stuff. Not, as you have all been doing very politely for the last 50-odd minutes, sitting, listening, and, occasionally joining in. Being active, making things matters. Again, Pete has this in the Scary report. Encourage students to be creative with their digital skills through teamwork and projects. Obviously not for the A-level NEA because there are special rules, but those rules don't apply to the GCSE computer programming requirement. You have to just say that they have had the opportunity to do some programming. I know there's a little bit more to it than that. It doesn't say on their own, under exam conditions. GCSE computer science, do whatever you want in that programming bit, but they have to do some programming. So you can, use the internet, use ChatGPT. I think creativity really matters. Everybody has their own definition of creativity, which is really creative, isn't it? Mine rests on these 5 aspects. I think creativity is where you're making something that didn't exist, either virtually or physically, where you care about the quality of it. It's not just, dash this off, that's fine, I've written a poem, look. It's where you actually want this to be the best it can possibly be, where it is, in at least some sense, original. This thing has never been made before. This unique physical object, virtual object, is new, brand new, wasn't there before. It demands a certain fluency with the tools, that you have to be competent in the medium. And yes, that you connect to a community of other makers. And you've got a community of other makers there in your classroom, there. Again, digital creativity is not, I don't think so. That's why I'm not comfortable with the Yuki model of, how we go forward with GCSEs. I don't think it's you can do computer science or you can do creativity. I think the creativity is part and parcel of all of this. Simon told you right at the start, computer science is a creative discipline. I think he's right there. The people who got this best are, of course, MIT and the Scratch team. And before they had Scratch, they had the Computer Clubhouse, technology culture that members can join by speaking the language of technology, creating, building, sharing projects, very much like professionals do in their design studios, yeah? If you want them to go off and join software houses or whatever, then being able to work creatively and cooperatively with other people, probably really important, not during the A-level NEA. Okay, Resnick gets it right. You build something in the world so you get an understanding of the thing in your head. It's only through making the thing that you truly come to understand the ideas there, yes? That it's not assessment of learning, it's assessment as learning. Persuading my trainees that that's why they need to write the essay themselves is non-trivial, okay? Coding is not the message of the curriculum, it's its medium, yeah? The lab work of computer science motivates, illuminates, brings to life the, he says, dry bones of theory. Without programming, computer science would be a dry theoretical husk of a subject, yeah? I'm not saying programming is the only thing where they're making stuff. Simon is, but I'm definitely not saying it's the only space for the creativity there. But making things does seem really important. Resnick, again, father of Scratch, the means of production now are in the hands of the people. For most of human history, the tools of creative production were in relatively few hands. Digital revolution has put sophisticated tools within reach of almost everyone. But even the most accessible are worthless without the ideas and expertise for those who use them. And I think that's true post-AI as it was pre-AI. Children are born with the capacity to be creative. You look around your year 11s, you look around your 13s and think, are they all really creative people? If they're not, what went wrong for them? This has to be a thing that's nurtured and valued by teachers. I hope you are creative. You make things. You make lesson plans, you make resources. Many of you, I hope, are still making code or making digital media. Yeah? Share your creativity with your classes. Again, Resnick, Scratch has these vast number. I think the billionth Scratch project is up there on the site now. That's 1 for every 8 people on the planet, whatever the statistics is. Yeah? I'm not saying it's 1. Okay. Some people have done more than 1. And why is Scratch so phenomenal? It's not the lovely building block interface. That helps. It makes it accessible. Means you don't make syntax errors. You can see what's going on. It's because of the community site that is fully integrated into how Scratch works. You build a project. You don't answer a question. You don't solve a problem. You choose what you make. You play at it. You tinker with it. And you have a group of people who will come in and talk to you about it. So, folks, we are pretty much at 3 o'clock. In summary, get your kids asking questions of one another because of what you pose in front of them. Get them asking you questions. Set time aside in class for. I want you to all write down a question you have thought of during this lesson. Show those on your mini whiteboards or post it onto Google Chat or whatever you're using. Start from where they are. What is it they're interested in learning? It won't always be the components of a computer, but it may not always be bubble sort either, okay? It may be, can I make music with code? Can I make my own Instagram filter? Can I look at the patterns that are there in the weather or in my friendship circles? Show them how it's relevant to what they are interested in, their culture, particularly, I would argue, to their career ambitions. Show them how this is useful for what they care about, for what they want to do. Let them work together, please. Yes, why not? You know, what's the worst that can happen? Yeah, not during the NEA courseworks, obviously. And most importantly, I would argue, have them making stuff. Yeah, not just here's what I prepared earlier, but, you know, actually rolling their sleeves up and getting it wrong and having to persevere. Maybe getting the AI to help a little, but getting their friends to help a lot as well. And just keeping going when it gets hard. These slides are all online at the reasonably memorable URL, which is on the slide screen behind me. Thank you so much for coming along to this and for joining in. Really appreciate it, folks. Thank you.